All right, so we're going to draw those dot structures for covalent compounds. We've already done ionic compounds, so these are going to be for covalent compounds. All right, so we want to be able to draw these structures. So later on, we'll be able to take these structures and identify what shape they are, like what geometry they are, and then we can figure out if they're polar or non-polar, what intermolecular forces are going to be present, and all that sort of stuff. So, but for the most part today, it's just going to be just drawing the structures, and really the thing that we're going to keep track of, and that's most important to us today, is we need to watch all the valence electrons. So we need to be able to identify the number of valence electrons in an atom. Are there any questions about how to do that? All right, so you should be pulling out your periodic table right now. We're going to use that, right? We need to have our periodic table in order to identify the number of valence electrons in an atom, okay? Because we can identify it by the group number that they're in. And we're only worried about main group elements here. We are not worried about anything else except main group elements for this. All right? All right, so remember, bonding is done through valence electrons here, and the whole idea is that in a covalent compound, we are sharing electrons to reach a full valence shell. Okay, so for the most part, that means that we want the octet rule satisfied, right? But there's an exception to the octet rule. There's a few of them, but what's probably the most glaring exception to the octet rule? Yes, sir. Yeah, the first layer of the periodic table, hydrogen and helium. Good. They only want 2 valence electrons, right? And they're pretty happy. All right. Okay, so here we go. So here are the steps or the instructions on how to draw these. Okay. Step number 1. We need to count the total number of valence electrons in the molecule. Okay, so for example, our example that we're going to run with today, let's start with calcium fluoride. Okay, we're going to try and figure out what the structure is for calcium. Carbon fluoride, right? Carbon tetrafluoride. All right. So we need to count the total number of valence electrons in the molecule. So how many valence electrons does carbon have? 4. Yeah, it's got 4. What's the total number of valence electrons with the fluorines? What? Nope. 7, but how many fluorines do we have? 28 total though, right? Because we have 4 of them present. Right, so 7 times 4, right, gives us 28. We have a total number of 32 valence electrons to dish out. Everybody see where those numbers are coming from? Understand? Okay. Fluorine is in the 7th row of the periodic table. It's got, or 7th column periodic table. It's got 7 valence electrons. So when we have 4 of them in the compound, so 7 times 4, 28. Okay. All right. So next thing, we want to put the, I'll say usually, the least electronegative element in the middle and bond it to the other atoms all around it. Okay, so we want to bond everybody, put the least electronegative one in the middle, and bond everybody else around it. So that means I'm going to draw a carbon in the middle. Okay, and I'm going to surround it with fluorine. All right, and I'm going to bond them all together. 1, 2, 3, 4. There we go. How many electrons does each single bond there represent? 2. And how many bonds did we draw? 4. So 2 times 8 means we've used up, or 2 times 4 means we've used up 8 electrons. So 13 minus 8 gives us 24. Good. All right. Third step. Add electrons to outside atoms. Okay, so if I look at fluorine, right there. Fluorine, how many electrons does it want to have around it? 8. Okay. How many more does it need around it? It only has 2 that's being shared with it right now. So we got to add some lone pairs of electrons around it. So we're going to add 6 more to each fluorine, right? Okay. So we've got 1, 2, 3, 4, 5, 6. So do you see how fluorine has 8 total electrons around it now? Okay, and I'm gonna make sure that all of the atoms around the outside are happy. Right. Well, how many electrons did we use up there? 24. Right? 6 times 4 is 24. Okay, so minus 24. 0. Ooh, we're out of electrons. Okay, once you run out of electrons, you want to make sure everybody's happy. Okay, so if everybody's happy, we're done. So let's check to make sure. I look at fluorine here. There's 2, 4, 6, 8 electrons around each fluorine, right? Fluorine's good. Okay, what about carbon? 2, 4, 6, 8. Carbon's good too. All right, we're done. All right, there we go. There's the structure of carbon tetrafluoride. Okay. All right, then let's do another example because we got a few more rules to get here. So I'm gonna move this off to the side. And I'm gonna do another example here. Let's do about CO2, carbon dioxide. Start by counting the valence number of electrons. Carbon has how many? 4. What about oxygen? 12. We got got a total number of 16 valence electrons to dish out. Right? Okay. So put carbon in the middle. Bonded to each oxygen. How many electrons do we use up there? Four. And we use 4, so minus 4. So we got 12 left over. So we're at the third step now. Add electrons to the outside atoms. All right, so each oxygen needs 6 more, right? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So I used 12 electrons, 0. Got to do one more step here. Yeah, 1 second. What's that? All right, so we got two problems that are going to develop here. We made the outside atoms happy, right? But we're out of electrons, right? Each oxygen has 8 around them, right? Okay, they've got 2, 4, 6, 8, 2, 4, 6, 8. But carbon only has how many? It's only got 4, 2, 4. Carbon's not happy yet. Okay, so we have 2 more scenarios, 2 possibilities here. Hey, in one scenario, you have no electrons left. All right, if that's the case, if you don't have any electrons left, okay, this is basically if you don't have any electrons left, you need to start double and or triple bonding. Right, because we got to start sharing more electrons than just the 2 between the 2 atoms to make sure everybody's happy. All right, so, well, what can we do here? We can take 2 electrons, a pair of these electrons off of oxygen, okay, and share it between the oxygen and carbon. And then I'm going to take another pair off the other side, share it with those 2 electrons, with oxygen and carbon. Okay, and notice what we have now. 8 electrons still around oxygen. 2, 4, 6, 8. 2, 4, 6, 8. And now with carbon, we've got 2, 4, 6, 8 electrons around it as well. Yes. No, everybody wants 8 total electrons around it. It starts with 4 valence electrons, but it needs to gain 4 more to have a full valence shell of 8 electrons around it. Okay. All right, so there you go. Now we have another option here that can happen. We could also have extra electrons. Okay, if we have extra electrons, we're going to add to the center atom. Okay, add them to the center atom. Now, in some cases, you can have more than 8 electrons on the center atom. called the expanded octet rule. All right, and this isn't just for, you know, putting extra lone pairs on there. You can have more than 8 electrons, but the deal is that the atom must be in the third row or below of the periodic table. Yes.
The lines that indicate the bonding between the atoms, are those always going to indicate 2?
Always 2 electrons. Yep. A line, one single line is always 2 electrons.
Wait, why did you take the CO2? Why did you take away from 16?
Because I started out by bonding, right? Each oxygen was bonded once, right? That was one line between each. One line, each line represents 2 electrons. All right, so let's do one of these examples here where we're going to end up having to use, we're going to have extra left over. Okay, something like, how about ClF3, chlorine trifluoride. Yes.
What did you mean when you wrote third row below?
Third row of the periodic table or below.
Oh.
Yep.
Will there be any cases where you'll have more than enough left, or none left and then you have all
Oh yeah, I mean we just had one where we didn't have any left, right? And carbon and oxygen are in the second row. Or do you mean like?
you said, oh, if you have extra left.
Yeah, if you have extra left and they're in the second row, chances are you did something wrong. Yeah, that's a prime example of you added the total number wrong. Okay. So we're going to do some stuff here with the total number of electrons here too. Is that there's 2 spots here that if you have a negatively charged like anion, you add electrons for each negative charge. Okay, and if you have a positively charged anion, you subtract electrons for each positive charge. So we'll get to those in a second. We'll do examples of that in a second, but those are some other, that's a typical error that will be made with an anion or cation. You'll have the wrong number of valence electrons and you'll have some left over, but you can't put them on there anywhere. Or you come up short 1 or 2, so it gets a little funky. But we'll do some examples of those. Those are a little more difficult. All right, so let's do this one though. So chlorine tetrafluoride here. Trifluoride. Nice. Come on. Okay. So chlorine has how many electrons? How many valence electrons? 7. Okay. Each chlorine has. So we got a total of 21. So we got total valence number of electrons of 28. Right. So we draw chlorine. Surround it with fluorines that are bonded to it. Each one of those bonds uses 2 electrons up from our total. So what am I going to subtract here?
6.
6. I got 2, 20 left over. So we go ahead. Next step, we got to make the outside atoms happy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I used up 18 electrons. I got 4 left over. So I got extra electrons left over. We got to add them to the center atom. Is it okay that we're adding them to the center atom? Yes, it is, because chlorine is in the third row of the periodic table. So those any atom that's in the third row of the periodic table or below can have an expanded octet. They can have more than 8 electrons on them, so I'm just going to add a lone pair here and add another pair here. And there we go. -4. That's 0. At 0, and everybody is happy. Each fluorine has 8 around it, and chlorine happens to have more than 8. Booyah. All right. All right, so let's practice some of these. So I want you guys to do the first 10. You only have to do, only doing the first column for homework tonight. First column, first 10, 1 through 10 only. This is for everyone behind me.